Hello everyone, it is time for another of my monthly dev status videos. Just want to show you what I've been working on over the past month. You can see that progress continues. This will be a briefer update than last time. Last one was kind of long, but that was probably because I hadn't given an update in a while. So the point is to try to give you sort of smaller bite-sized updates. I do have some new stuff to show, but not a ton on the surface because a lot of stuff is being worked on behind the scenes. But let me just show you real quick. The first detail will be a little bit more mathematical in nature, and from a feature or user level may not be that interesting, but in terms of the development progress, it is actually pretty important and a big step forward. So as I've done before in the past, you have your pitch curve assemblies, which you can assemble, sort of a whole network of them. And what I needed following the last video, at that point, I had not set up the code I need to compute tangents and curvatures, which are topics from vector calculus. I won't go too much into the details of them, but let me remove the transformed case here. But what you can see is, a tangent, as you may recall from geometry, is just a line that just flatly lies along the curve. To be able to compute my involutes accurately, I needed to be able to compute with high precision the tangent vectors at any point of contact, which, as you see displayed here, is now being computed. And these are actually very, very accurate calculations. You can't appreciate that just from seeing it here, but it's more than just doing a fine sampling. It's actually doing the vector calculus to figure out what those tangent values are. Also works for the rack gear as well, works for everything. So that was a big achievement over the last month, because that was there was a fair bit of math I had to finish getting ironed out. Most of it was already done, but I had to figure out a few remaining things and get the theory all just kind of tied together, and that came out very, very well in the end. In addition, I can actually compute curvatures. Now, this is moving very fast. Let me just kind of pause it. So, and let me also eliminate too many curves here to make it hard to appreciate what's going on. I'll keep that one and hide all but this one. So the curvatures is another topic from vector calculus. Is basically for any point along the curve, you need to figure out a circle that approximates the curve at that point, and that is useful for various calculations. In general, vector calculus, and in particular in my case here. I am doing an approximate curvature calculation using a 3-point circle sampling along the curve. Close to that curve, I take 3 points and draw a circle from them. And the point is to see if I am reasonably accurately calculating the curvature. And if I'm doing it correctly, this red circle should fall right inside of this cyan circle, and that's happening precisely in this instance, which is means that the curvature is correct. Only this one, the red one's only an approximation, it's only so accurate, but the cyan one is extremely accurate. So that's just sort of infrastructure I need to do my calculations, but as a monthly retrospective, and just stating that that's one of the things that was achieved, and that was a big step forward. All right, now into stuff that'll be slightly more interesting from the user perspective. Here I have in a very early user interface form. There's a whole bunch to mature here. This is a very early stage, more in a prototype state at the moment, but it's rapidly being developed and fleshed out. But where do I begin? So effectively what I can do here is this is just working with the initial starting design pitch curve, and I can calculate a tooth distribution. So basically what it's going to do is calculate the involute tooth lengths along the curve according to the very precise formulation that I've derived, which is appropriate for these curves. So a few things you'll notice about them is that there is generally some slight variation in the shape, and from one area to the next, you'll notice that not every tooth is exactly the same, and that is as intended because that's how these non-circular involutes work. I will say that the exception to that is here. You see some very dramatic, uneven adjacent tooth lengths here. And that's not how it's supposed to be. That's simply an artifact of the way it's programmed thus far because I'm not correctly handling the fact that this curve is a loop. When calculating the involute curves, you have to take into account the shape of the neighboring pitch curve. And here, the curve terminates early before the calculation is finished. It won't do that in the finished version, but right now it's just because it's not finished being coded yet. So that will be handled, but you won't have to. And then it'll look much more even and appropriate. Now, obviously, also these flanks are open right now, so I need to compute basically the peaks and valleys as well. And that will be another thing that you can parameterize the control for. Now, one thing that's going to be important, I'm going to demo here, is this Dsdu curve. I might call it the tooth size or the tooth spacing curve or something like that. But it will often be important. In fact, let me go back and modify this curve a bit to something a bit more, something that has a little bit more of a concavity, like so. So let's say you are designing a gear that has this shape. So an issue that can occur is that the tooth flanks are forced to be shorter in this instance because of when you have these tight interior corners, because of the way the geometry is defined and for various other reasons, you have to limit the size of the teeth. Otherwise, the math effectively falls apart. So generally, the tooth flanks have to shrink a bit, particularly towards the concave side of the curve. You can see they're very short here. Sometimes, because those flanks are so short, you might want your tooth distribution to be more dense in this region. And that's where this curve comes in. The idea of this curve is that what you can do is I'll place a few control points here and there, and I can actually start to shrink this sort of slinky-like display I have here. I don't know if that's how I'll present it in the final version, but it is pretty visible at least. But basically what this is going to do is this is going to control for the size variation of the teeth. Now I haven't updated the tooth flank calculation yet, but I'll do so now. So I'll set calculate distribution, and there we are. Now we remove this slinky curve, and now you see that the placement of the teeth now has varied continuously with that curve that I created. And if I want, I can make it a lot more dramatic and just shrink it down even further, like so. Calculate like that. Nice. And you see that you have this nice continuum of the tooth flanks, starting reasonably large, but then shrinking down. Now, also in theory, I can take the, you change the number of teeth, of course. Oops, 64, and I can make it even finer. And this is just like one of many different parameters you'll be able to control for. Let's see, what else do we want to do here? Yeah, so I mean, for instance, you could say, you could also make this, more uniform in this region. And I need to work on the tooling a little bit to make this a little bit more user friendly. But the idea will be that this curve effectively will determine how your tooth size will vary. This guy here, a little bit better. Shrink this one down well a bit. All right, so it's a little bit more even, so instead of flaring out as rapidly. And yeah, you can make this curve whatever you would want it to be. Calculate the distribution again. Cool. So yeah, and then this will be one of the ways. There'll be several ways you can address what you do if you have an interior corner that is, high curvature. There you can do things like adjust the pressure angle and so on. So there are a lot of other. This is just one of many curves you're going to be able to manipulate, and that's a big part of what I'm working on right now. Since I think most people prefer to watch the demo video last time, I do want to restate that unfortunately this release is going to be Windows only. I had initially announced it was going to be a web application, any device, any platform, but due to some technical problems with the technology stack, I've opted to go with a Windows only release for starters, and then hopefully at some point work on porting it to be cross-platform. I also gave out some details about the pricing in the last video, so you can, in the last detailed status video, not the demo video, the other one. So you can check out that if you're interested in that as well. So just don't want you to miss those details because they are there. So, all right, that's about it for this video. I hope you enjoyed. I'm going to be working heavily on this part, essentially getting all the tooth parameterizations working in all possible scenarios. And this is what I call the beast, because it's easily the hardest part of the programming. So this is kind of a major hurdle for me to get past. Hopefully on the next status video, I will have all of this figured out, if not most of it. So, all right. Hope you all enjoyed. Feel free to email me with comments or questions. Thank you.